Now see a Bohr's model of hydrogen atom. So we have discussed about the atomic model which was suggested by Rutherford. But see here, whatever the atomic model was suggested by Rutherford, it has got certain drawbacks. First one is Rutherford suggested that every atom has got a tiny core that is called nucleus, like this is your positively charged, and electrons revolve around it. You know, according to the classical theory of electromagnetism, when electrons revolve around it, they are accelerated, and when they are getting accelerated, they should continuously emit radiations. If they are emitting radiations continuously, their energy should decrease continuously, and ultimately an electron will fall into the nucleus, and the atom or the nucleus will collapse. But it does not happen. So actually here Rutherford model could not explain here the stability of the atom. And another one, when electrons are revolving and emitting radiations continuously of all frequencies. So a spectrum obtained must be a continuous spectrum, but it does not happen. We have seen that the spectrum or the line spectrum not continuous. So also this spectrum could not be explained by Rutherford. So these are the 2 points which are taken as the limitations of Rutherford's model of atom. Now let us see Bohr's model of atom. So Niels Bohr explained atomic model, and he has given some postulates. First postulate is every atom consists of a tiny core that is called nucleus, which is positively charged, and electrons revolve around the nucleus in a stable orbit or in the circular orbits, and these electrons get centripetal force due to electrostatic force of attraction between the electrons and the nucleus. So this was the first postulates of the Bohr's. Now according to this, when this is a positive charge and the electron is revolving around the nucleus, it must have the centripetal force, that is mv square upon r, where m is the mass of the electron and r is the radius, v is the velocity of the electron. It must have this is equal to here whatever the charge is here, that is a Ze, and here is E. So we can write here Ze into E divided by 4 pi epsilon naught r square. So this is the first postulates of the Bohr's theory. And now see here the second postulates. According to Bohr's second postulates, electrons revolve around the nucleus in a stable orbit, and the angular momentum of the electron is integral multiple of the h upon 2 pi. So we can write here in the second postulate L is equal to nh upon 2 pi, that can be also written mvr is equal to nh upon here nh upon 2 pi. This is the second postulates. Now the third postulates of the Bohr's atom is when the electrons remain in in a given orbit, it does not radiate any energy, but as the electron is given some energy, it jumps from the lower orbit to higher orbit. And when the electron jumps from the higher orbit to the lower orbit, outer orbit to the inner orbit, it radiates energy. Suppose the electron is jumping from outer orbit to inner orbit, it radiates energy that is equal to actually h nu is equal to E2 minus E1, and E2 is the energy, it is energy of electron in outer orbit, and E1 is energy of electron in inner orbit. So when electron jump from outer orbit to inner orbit, it radiates energy, and that energy is given by that is equal to h nu. So these are the three postulates of the Bohr's theory.